Mr. Said is on the call now, Madam Franca.
Yes. Anyway, we've spoken, so it's okay. He'll moderate, and I'll take this. Yeah. We discussed.
Okay, go on.
Yeah.
Okay, go on.
Okay. So good afternoon once more. Can you all hear me though?
Good afternoon. We can
Good
hear you very
afternoon.
well. Loud and clear.
Okay. Yeah, I'm going to take Microsoft Security, Compliance, and Identity Fundamentals. Yeah, and I'll introduce myself. Said will be moderating today. Said, are you on call? Okay, I'm the CEO at Cheska Global Solutions, a Microsoft certified trainer, data analyst associates. I'm a professional with professional Scrum Master, IT and cybersecurity consultant. Okay, for this class, I'm going to take SC 900. SC 900, it's the Microsoft Security, Compliance, and Identity Fundamentals. And an overview is here we'll learn about the concepts of security, compliance, and identity. We'll also learn about the capabilities of Microsoft Entra, the capabilities of Microsoft Security Solutions, and the capabilities of Microsoft Priva and Microsoft Purview. The SC 900, the learning patterns, describe security and compliance concepts, identity concepts, and security and compliance concepts. Okay, we'll also look at the shared responsibility model. The responsibilities vary based on where the workload is hosted. Yeah, we have software as a service, SaaS. We have the PaaS, platform as a service, and we have IaaS, infrastructure as a service. The on-premises data center, refer to this as on-prem. So in an on-premises data center, you have responsibility for everything from physical security to encrypting sensitive data. Okay, if since you're in this class, yeah, can somebody tell me who knows about SaaS? Can you tell me anything about SaaS? Can somebody unmute and tell us about SaaS? What do you understand by SaaS? SaaS or IaaS? SaaS, IaaS, or PaaS? You can take anyone. I can't see your hands up, so please, either moderator, pick somebody, or anybody can unmute and speak. Hello? I'm not on that screen. Do we have any hands up? Hello, are you there?
Yeah, we can hear you loud and clear. I'm waiting
Yes.
for somebody to shoot the hand up.
Okay. Yeah, this is a security class, so we should know something about SaaS, PaaS, or IaaS. Nobody? I can't see any hands up.
Sorry, what?
Yeah.
Can you please come again? Good afternoon.
Good afternoon. Yeah, I asked the question. I said, can somebody tell me what he or she understands by SaaS, IaaS, or PaaS? You can take anyone.
Okay. Infrastructure as a service.
Okay.
Have software as a service, that is SaaS. And I think the last two, infrastructure as a service, that basically has to do that when you pay for services from the cloud. The infrastructure is hosted by the cloud provider. And when you talk about software as a service, basically the hardware the only thing you are software as a service is basically used like when you have your apps, like your power apps and all that, are basically things like software as a service. So basically, you are provisioning with your cloud provider. The only thing you are considering is your application, which you are running. I think then software, yeah, that's how I understand. Infrastructure basically means that they are providing the VMware, the hardware, and everything for you. They are hosting it on the cloud for you. You don't have to consider the VMwares and all that. Then when you take software as a service, that means even the apps and everything, they are hosted. So you're just logging in and using the software online on the cloud. I think there's also another one, the third one. I can't remember that one.
PaaS, the platform as a service.
PaaS.
Yes.
Platform as a service.
Platform as a service.
Platform as a service, basically. Sorry, I think platform as a service, basically, I think the infrastructure provided by the cloud provider, but the platform, basically, that will be your app and all. I think you might be the one. I think most of the developers are the ones who go for that. Sorry. So platform as a service, that's like the power apps and all that. Then software as a service, basically, you the developer is using your software, loading it. I think that's my understanding. I'm not too sure. I'm getting differentiation, but I think that's what I can remember.
Okay, you did well. You did well. Yeah, you did well. Okay, so infrastructure as a service, of all cloud services, infrastructure as a service requires the most management by the cloud customer. This is referred to like a shared responsibility. Microsoft, takes care of the infrastructure, while the customer or the user, so the IaaS, you're using the cloud provider's computing infrastructure. That's Microsoft in this case, Okay, the cloud customer isn't responsible for the physical components. It's Microsoft that handles the infrastructure, the devices, the computers, the networks, or the physical security of the data center. It's handled by Microsoft, the provider, who is the provider here. However, the cloud customer still has responsibility for software components, such as operating systems, network controls, applications, and protecting data. So that's IaaS, that's the infrastructure as a service. And you have the platform as a service, which provides an environment for building, testing, and deploying software applications. So the goal of PaaS is to help you create an application quickly without managing the underlying infrastructure. So with the PaaS, the cloud provider manages the hardware and operating system, and the customer is responsible for applications and data. So that's the platform as a service. So like I mentioned to you, all these, they're shared responsibilities. The customer handles the applications and the data in PaaS, while the provider, the cloud provider, handles the hardware and the operating system. Okay. Then you have the SaaS, which is software as a service. This is hosted and managed by the cloud provider, for the customer. It's usually licensed through a monthly or annual subscription. Examples are like your email, Microsoft 365, Dynamics CRM Online. These are examples of SaaS. All you need to do is pay for the subscription and use it. You don't have to know the nitty-gritty of, you don't need to, you're not bothered with the infrastructure. Just go there, use it. And this can be likened to like you going to a hotel to have your meal. You just go there and they serve you. That's SaaS. Okay, SaaS requires the least amount of management by the cloud customer. Remember, you don't bother with the infrastructure. All you need to do, just like your email, your Microsoft 365, you're not bothered about how it was built or anything. Yeah, you just use it. So the cloud provider is responsible for managing everything except data, devices, accounts, and identities. So for all cloud deployment types, you, the cloud customer, own your data and identities. You're responsible for protecting the security of your data and identities and on-premises resources. When we say on-prem, what do you understand by on-prem? Can somebody tell us? What's on-prem? I did mention that you have on-prem, you have SaaS, PaaS, and IaaS. What do you understand by on-prem? On-premises. Anybody? You can unmute and speak. Okay. On-prem is where you have to pay for the storage, you pay for the hardware, the infrastructure. Yeah. But with the cloud services, you don't have to, you have to pay for everything you need. Yeah. But for the cloud services, you just pay for what you need. Yeah. So you don't have to pay, like if you pay for the storage you need, you pay for, as need arises, you pay for it. So it saves a lot of money, yeah, to use a provider, yeah, to have them on the cloud. So in summary, responsibilities always retained by the customer organization include information and data, devices, and accounts and identities. Yeah, so the customer usually retains that. Yeah. Defense in-depth. Defense in-depth uses a layered approach to security. Examples include the physical security, limiting access to a data center to only authorized personnel. That's your physical security. And you have the identity and access security. Yeah, this controls access to infrastructure and change control. So you have the perimeter security, you have the network security, compute layer security. These are the different layers of security. Yeah, you have the application layer security, and you have the data layer security. Okay, the perimeter security is distributed denial of service, that's DDoS, protection to filter large-scale attacks before they can cause a disruption for users. So that's the first layer. Then you have the network security, which limits communication between resources using segmentation and access control. For this, you can liken this to, like if you have like segmentation, where you have in your house, you have different doors. You have so many doors. Yeah, and when you lock a door, yeah, you limit access. The people don't go in. Yeah, so you have keys to the doors. It's only people that you give a key to your room to that will access it. And you have the compute layer security. This is securing access to virtual machines by closing certain ports. You have the application layer security. So these are the different layers. You have this ensures applications are secure and free of security vulnerabilities. And the last layer is the data layer security, which controls access to business and customer data. They use encryption to protect data. Encryption Can somebody tell us, what do you understand by encryption? Hello? What do you understand by encryption?
Encryption is when you have a code to limit access to your data.
Okay.
And yes, that's my name.
Okay.
Answer.
Yes. Okay, like when you encrypt your data, it's not readable.
Yes.
Yeah.
Yes.
Very good.
Yes.
Yeah. Yeah. That's good. Yeah. So when you can encrypt your data if you don't want people to read it, and it's only people that you give the key to that can decrypt it. Yeah. So that's a way to secure your data. Enterprise security needs to adapt to this new reality. So the security perimeter can no longer be viewed as the on-premises network. It now extends to SaaS, applications for business critical workloads that might be hosted outside the corporate network. And you have the personal devices that employees are using to access corporate resources while working from home. We have a lot of people working from home now. Yeah. And that's a security challenge because you don't know what your employees are doing. Yeah. So we have this BYOD, bring your own device. Yeah. So you have cases where you have like disgruntled, like people, disgruntled employees. They can harm your computer. Yeah, so you need to be careful. That's why we need to know about security. The unmanaged devices used by partners or customers when interacting with corporate data or collaborating with employees. I have the IoT devices installed throughout your corporate network and inside customer locations. What do we understand by IoT? What's IoT? Can somebody tell us the full meaning of IoT? What's IoT? Anyone? IoT. What does that stand for? Hello.
Internet of Things.
Yes, Internet of Things. Yeah.
Internet of Things.
Okay. Yeah. Okay. So defense in-depth uses a layered approach to security. Yeah, you're correct. Yeah. Rather than relying on a single perimeter. So a defense in-depth strategy uses a series of mechanisms to slow the advance of an attack. Yeah, so we just went through this defense in-depth layers. Yeah, so it slows down the advance of an attack. It goes through these different layers. Yeah, so each layer provides protection so that if one layer is breached, a subsequent layer will prevent an attacker getting unauthorized access to data. So if a hacker goes through one layer, it might not succeed in going through another layer. Yes, that's why you have several layers. Yeah. Okay. Then we have we've looked at this different layers. Yeah. Talks about the physical security, such as limiting access to a data center to only authorized personnel. Yeah. So with these layers, you can limit access to only authorized personnel. You don't want unauthorized personnel to access your resources. Yeah. So you have the identity and access security controls, such as multi-factor authentication or condition-based access to control access to infrastructure and change control. Can somebody tell us what do you understand by even the word authentication? What's authentication? And somebody tell us the word authentication. What do you understand by that? Anybody can unmute and yeah, go on.
Authentication means
Authentication has to do with
originality.
Sorry, say that again.
It has to do with originality, authentic. Like when something is authentic, it's an original. I don't know.
Original, okay. That's the English word.
Okay,
Yeah. Okay, go on.
by me has to do with authentication has to do with your being. Do you have access to connect to?
Okay.
Are you a legal entity? Are you authorized? Authentication has to be, are you authorized and being verified to log in? So you're being authenticated. That is do you have that role to?
Okay, that's
okay.
And when you not have that role, you log in and you are allowed to enter.
Okay, that's good. Yeah. Anyway,
authentication means are you who you say you are?
Okay. Yeah, authentication is verifying that you say that you are who you say you are. Yeah. You need to verify that. If you say you are Greg, verify it. Yeah, verify that you are who you say you are. Yeah.
Yeah.
And you have the multi-factor authentication, even on your phones. Yeah, remember you have multi-factor authentication. Yeah. You need to like verify that you're who you say you are. Like if you go to a hotel, yeah, you need to, if you say your name is Greg, yeah, show me that you're Greg. You need to show with an ID, yeah, present your ID to say that, to prove that you're Greg. You need to verify that you are who you say you are. That's authentication. So multi-factor authentication is first, okay, you have your password. Yeah, you have your password. So you need to, a second authentication could be your, like when you authenticate at times, it gives you a code. Yeah, even when you're using the system and it's asking you for your MFA, yeah, it will send a code to your phone, yeah, to verify that you're who you say you are. Do we get that? Yeah. Okay. So to access, to control access to infrastructure and change control. And you have the perimeter security of your corporate network includes distributed denial of service, DDoS, protection to filter large-scale attacks before they can cause a denial of service for users. Yeah, these are the different layers. You have the network security, yeah, such as network segmentation and network access controls to limit communication between resources. Like the example I gave, you having access to the rooms in a house, you need the key, have to be given a key to access it. Then you have the compute layer security, such as securing access to virtual machines, either on premises or in the cloud by closing certain ports. The application layer security to ensure applications are secure and free of security vulnerabilities. Yeah, you have the data layer security, including controls to manage access to business and customer data and encryption to protect your data. Yeah. So yeah, okay, in security, what does CIA stand for? Does anybody know that? CIA? Can somebody tell us? Can unmute and let us know. CIA. Anyone? Is there any hand up? Anyone wants to try? CIA. Okay, Greg, go on. Right, you can unmute and speak. Yeah.
Confidentiality, integrity, confidentiality. Can you hear me? CIA.
Yeah, I can hear you.
Confidentiality, integrity, and availability.
That's very good. Yeah, so CIA stands for confidentiality, integrity, and availability. Yeah. Okay, here confidentiality ensures sensitive data, such as customer information, remains confidential. Yeah. You don't want like your data to be thrown all over the place. Like if you go and buy, say, granuts, you don't want people to, you don't want your data, people using that paper that you use, the form you filled with all your information, yeah, to wrapping granuts and all that. So it has to be confidential. Yeah, ensure that sensitive data is confidential, shouldn't be thrown around. And integrity ensures data or messages haven't been tampered with. Yeah, integrity. Yeah, data should not be tampered with. Yeah. And availability refers to making data available to those who need it. Yeah, make available data to those who need it, availability. So the concept of a defense in-depth strategy that uses a series of mechanisms to slow the advance of an attack. All the different mechanisms, technologies, processes, and training are elements of a cybersecurity strategy, whose goals include ensuring confidentiality, integrity, and availability, referred to as CIA. Okay, so we all understand what confidentiality is. Yeah. The data has to be confidential. This refers to the need to keep confidential, sensitive data, such as customer information, passwords. Your password shouldn't be shared with anybody. Shouldn't share. We all know that. Yeah, don't share your password with anybody. Or financial data. You can encrypt data to keep it confidential. Remember, I did mention earlier that if that you can encrypt your data if you don't want anybody to read it. Yeah, to make it secure. So to keep it confidential, you can encrypt it, but then you also need to keep the encryption keys confidential, because if somebody accesses the keys, then they can get to the data. Yeah, confidentiality is the most visible part of security. We can clearly see the need for sensitive data, keys, passwords, and other secrets to be kept confidential. Yeah. So on integrity, this refers to keeping data or messages correct. You don't want anybody tampering with your data. People, you don't want when you know, this can be terrible if like you're dealing with payroll, yeah, and somebody adds a zero. You know, suppose you're paying like paying out say 10,000. If somebody goes to tamper with it and adds a zero to it, you know what that means. So, and also when you send an email message, you want to be sure that one received it the same way you sent it. You don't want it tampered with. When you store data in a database, you want it to be you want to be sure that the data you receive is the same as the data you stored. You don't want because even within, this can happen within the organization. Yeah, the internal staff could tamper with your data, they could tamper with your emails, database. So that's why you need to give access to only people that need access. Yeah, don't just give access to everyone. So encrypting data keeps it confidential, but you must then be able to decrypt it, yeah, when you need somebody to read it. Yeah. Okay. So integrity is about having confidence that data hasn't been tampered with or altered. Yeah. You need to, that's one of the, that's it on integrity. Then you have availability. The availability refers to making data available to those who need it, only to those who need it. Yeah, it's important to the organization to keep customer data secure. But at the same time, it must also be available to employees who deal with customers. Those that need it, you need to make it available to them. While it might be more secure to store the data in an encrypted format, employees need access to decrypted data. Yeah, for those that need it, you need to give them the keys to decrypt the data. Here, I'm going to talk about the zero trust model. The zero trust guiding principle. You have there are 3 guiding principles. When we say zero trust, it means that you trust no one, trust nobody. Yeah, zero trust. Don't trust anybody. Yeah, that's why you have to verify explicitly. Yeah, verify that you are who you say you are. Then give least privileged access. Yeah, don't give a user an access that they don't need. Yeah, just give the least privileged access. Give only the access they need. And assume breach. Yeah, assume that there's a breach already. Just assume. Don't trust anybody. That's zero trust. Trust no one. Assume that there's a breach. Okay, you have 6 foundational pillars. These are identities, users, services, or devices. And you have the devices create a large attack surface as data flows. Yeah, applications are the way that data is consumed. And data should be classified, labeled, and encrypted. Like I mentioned earlier, yeah, you don't want everybody accessing the data. It's only people that need it. Our infrastructure, whether represents a threat vector. Yeah, you have your infrastructures, the network should be segmented. So these are the 6 foundational pillars. Okay, zero trust, like I mentioned earlier, assumes everything is an open and untrusted network. Even resources behind the firewalls of the corporate network. So the zero trust model operates on the principle of trust no one, verify everything. Yeah, that's why we say verify explicitly. Yeah, you need to prove that you're who you say you are. Attackers' ability to bypass conventional access controls is ending any illusion that traditional security strategies are sufficient. Yeah. So by no longer trusting the integrity of the corporate network, security is strengthened. Yeah. So assume breach. Yeah. Zero trust. Trust no one. Yeah. So in practice, this means that we no longer assume that our password is sufficient. Yeah, because now hackers can get to your password. So your password is not sufficient. Yeah, to validate a user or add multi-factor authentication. Like I explained earlier, yeah, you need another step. Yeah, 2-step verification. That's multi-factor authentication. Yeah, to provide additional checks. Yeah. Just don't depend on your password, because hackers can break into your password and get to your password. Instead of granting access to all devices on the corporate network, users are allowed access only to the specific applications or data that they need. Yeah. So only grant access when you are giving permission in the organizations, when you are giving access to users, only grant them the least access. Grant them only the access they need. Yeah. So the zero trust approach to security transforms the security model into one that has three basic tenets. Like I explained earlier, verifies explicitly based on all available signals, employs the principle of least privilege access. Yeah, like I said, don't give users the more than the access they need. Give them the least privilege access. And always assume there's a breach. Yeah. Okay. So this approach should extend throughout the entire digital estate and serves not just a security philosophy. It also serves as an end-to-end strategy based on 6 foundational pillars. We've gone through this before, so I'm just going to skip this. Yeah. Okay, encryption. I did mention what encryption is the last time. I said encryption is the process of making data unreadable and unusable to unauthorized viewers. Yeah. You have encryption of data at rest. You have encryption of data in transit. I have encryption of data in use. Yeah. And you have the two top level types of encryption are symmetric, which uses the same key to encrypt and decrypt data. I have the asymmetric. So symmetric uses the same key to encrypt and decrypt your data, while asymmetric uses a public key and a private key pair. Yeah. So you have the symmetric and the asymmetric. Yeah. If you have any questions as I go on, please, you could stop me to ask. Any questions? Yeah? Okay. Or you could drop your questions on the chat. Yeah, one way to mitigate against common cybersecurity threats is to encrypt sensitive or valuable data, like I did mention earlier. So encryption is the process of making data unreadable and unusable to unauthorized viewers. To use or read encrypted data, it must be decrypted, yeah, which requires the use of a secret key. So if you need to decrypt the data, you could give a key to the users that need it. So there are 2 top level types of encryption. I did mention you have the symmetric and the asymmetric. Symmetric encryption uses the same key to encrypt and decrypt the data, while the asymmetric encryption uses a public key, a private key pair. So either key can encrypt data, but a single key can be used to decrypt encrypted data. That's for the asymmetric. While in the symmetric, that's why it's called symmetric, the same key that is used to encrypt and decrypt the data. So to decrypt, you need a paired key or symmetric. Asymmetric encryption is used for things like transport layer. Yeah. Okay. I did mention encryption at rest. Encryption at rest, yeah, is data at rest is the data that is stored on a physical device. Stored data. That's data at rest, such as a server. It may be stored in a database or a storage account. Regardless of where it is stored, encryption of data at rest ensures it is unreadable without the keys and secrets needed to decrypt it. Yeah, so data at rest. When you have the encryption at rest, that's you having encrypting the stored data on a physical device or database. So if an attacker obtained a hard drive with encrypted data and didn't have access to the encryption keys, they will be unable to read it. They won't be able to access it. Yeah. So that's why you need to encrypt your data. Yeah, your stored data and you use the encryption at rest to encrypt it. And you have encryption in transit. Data in transit is the data moving from one location to another, such as across the internet or through a private network. Yeah, it's in transit. So you secure transfer can be handled by several different layers. It can be done by encrypting the data at the application layer before sending it over a network. HTTPS is an example of encryption in transit, data moving from one location to another, to be on the internet. And you have encrypting data in transit protects it from outside observers and provides a mechanism to transmit data while limiting the risk of exposure. So you have the encryption in transit, you have encryption at rest, and you have encryption for data in use. So this is a common use case for encryption of data in use involves securing it in non-persistent storage, such as RAM or CPU caches. And this can be achieved through technologies that create an enclave. Yeah, so here you have, it protects the data and keeps it encrypted while the CPU processes it. Encryption for data in use, yeah, such as where you have data in your RAM or CPU caches. And hashing. These terms we need to know these terms as a cybersecurity person. You need to understand when somebody says encryption, you know what it is. Encryption at rest, all these terms. We need to be familiar with them as cybersecurity experts. Yeah, so that's why we're going through these terms. Then hashing, and this, like I mentioned, this is part of your SC900. Yeah, SC900, that's the security fundamental, Microsoft security fundamentals. Yeah. Hashing uses an algorithm to convert the original text to a unique fixed length hash value. So each time the same text is hashed using the same algorithm, and the same hash value is produced. That hash can then be used as a unique identifier of its associated data. Hashing is different to encryption in that it doesn't use keys. Yeah, the hash value isn't subsequently decrypted back to the original. So with hashing, yeah, you can't decrypt back to the original like you have in encryption. Okay. Hashing is used to store passwords. Yeah, when a user, I'm sure like each of us, we all have lots of passwords. Yeah, and remembering these passwords, yeah, it's usually an issue. I'm sure we all have that same problem. Yeah, with several passwords for different applications. So when a user enters the password, the same algorithm that created the stored hash creates a hash of the entered password. This is compared to the stored hash version of the password. If they match, the user has entered their password correctly. So hashing, like I mentioned, is used to store your passwords. Yeah, for every matched hash, they know the actual password. To mitigate this risk, passwords are often salted. Yeah. So this refers to adding a fixed length random value to the input of hash functions to create unique hashes for every input. Yeah, as hackers can't know the salt value, yeah, because that's another step, yeah, to secure your hash passwords. Yeah, so the hash passwords are more secured. Yeah, because I know we all have lots and lots of passwords. Yes, and to remember them is usually an issue. Okay, and let's look at governance, risk, and compliance, GRC, popularly called GRC concepts. GRC helps organizations reduce risk and improve compliance effectiveness. You have the governance, you have risk management, and you have the compliance. Governance is the rules, practices, and processes an organization uses to direct and control its activities. So when you talk about governance, the rules, yeah, practices, processes in an organization, yeah. And risk management refers to the process of identifying, assessing, and responding to threats or events that can impact business objectives. Risk management. And compliance is a country or region, state or federal laws, or even multinational regulations that organization must follow. That's compliance. And each organization needs to comply to the laws of the country. Yeah. Federal laws, and state laws, regions. So that's compliance. And we should take note, governance are the rules, practices, and processes an organization uses to direct and control its activities. That's governance. Yeah, some people always mix it up, compliance and governance. Compliance is the states or law or federal laws, yeah, regulations that an organization must follow. So that's the difference. Okay, and here I broke it down here. A structured approach for managing GRC helps organizations reduce risk and improve compliance effectiveness. Yeah. So you have the governance, like I did mention, the rules and practices, processes an organization uses to direct and control its activity. And many governance activities arise from external standards, obligations, and expectations. For example, you have organizations establish rules and processes that define the who, what, where, and when users and applications can access corporate resources. So it's the organization that would decide on who should access who, or where and what and all that within the organization, yeah, that can access the corporate resources, the organization's resources. Yeah, who had administrative privileges and for how long. And we have different privileges, like the, if you give a user an administrative privilege, that means they have the privilege to create, update, and delete. Yeah. So you remember we mentioned earlier on, I mentioned earlier on about least privilege. You don't give, you give the least privilege to the users. Yeah. You have different privileges. You can give a contributor or a viewer privilege. Yeah, some of the users, yeah, like somebody that has the viewer privilege is not allowed to delete or create. Yeah, they can only view, can only read. Then you have the risk management, which is the process of identifying, assessing, and responding to threats or events that can impact company or customer objectives. Organizations face risk from both external and internal sources. Even within your organization, yeah, it's you have some stuff that's can cause a lot of problem for the organization. So one needs to be careful. The risk could come from within or from outside. External risk can come from political and economic forces, weather-related events, pandemics, security breaches. Yeah, internal risk can come from within the organization, like I mentioned earlier. Yeah, itself, their staff, people that work in an organization. Examples include leaks of sensitive data. Yeah, they can leak your data, sensitive data, intellectual property theft, fraud. All this come from within. Yeah, all these are internal and insider trading. Yeah. And the compliance refers to the country, region, state, or federal laws, or even multinational regulations that an organization must follow. And these regulations define what types of data must be protected, what processes are required under the legislation, and what penalties are issued to organizations that fail to comply. Compliance. So it's important to note that compliance is not the same as security. However, security should be considered when building a compliance plan, as effective security is frequently a compliance requirement. Yeah, the difference between compliance and security. Compliance requires only that the legally mandated minimum standards are met. Yeah, whereas data security covers all the processes, procedures, and technologies that define how you look after sensitive data and guard against breaches. So take note, the difference between compliance and security, they're not the same. Compliance, you're dealing with the laws, legal implications, standards, yeah. While security covers processes, technologies, and all that. Okay, some other compliance-related concepts include you have the data residency, data sovereignty, and data privacy. Data residency, when it comes to compliance, data residency regulations govern the physical locations where data can be stored and how and when it can be transferred, processed, or accessed internationally. These regulations can differ significantly depending on jurisdiction. So data residency, yeah, refers to where your data is stored and how it is stored, and when it can be transferred, processed, or accessed. Data residency, where it is residence from the name. Yeah. Okay, and you have the data sovereignty. This is another important consideration. It's, data sovereignty. The concept that data, particularly personal data, is subject to the laws and regulations of a country in which it is physically collected, held, or processed. This can add a layer of complexity when it comes to compliance because the same piece of data can be collected in one location, stored in another, and processed elsewhere, making it subject to laws from different countries. Data sovereignty. Okay. So it's subject to the laws and regulations of the country, where it is stored, where it's physically stored. You have the data privacy. This providing notice and being transparent about the collection, processing, use, and sharing of personal data. Yeah. Your personal data, it should be private. You don't want everybody, you don't want it thrown all over the place. Yeah. So the principles of privacy laws and regulations. Personal data means any information, like you have your date of birth, you have your personal data, you have everything about you. Yeah, and it should be private. It shouldn't be thrown all over the place. Okay, so privacy laws encompass any data that's directly linked or indirectly linkable back to a person. Organizations are subject to and must operate consistent with a multitude of laws, regulations, codes of conduct, industry-specific standards, and compliance standards governing data privacy. Yeah. So your data, you don't want your data thrown all over the place. Okay, let's look at, can somebody tell us the difference between authentication and, first, you've seen what authentication is. Can somebody tell us what authorization is? What do you understand by authorization? Who wants to take that? You've been quiet for some time. So can somebody tell us what authorization is? Someone can unmute and tell us. Who is going? Hello.
Hello.
Hi. Yeah. Okay, go on. What do you understand by authorization?
Act of giving access to someone.
Okay. Giving access to someone. Any other person? Any other person? Okay. All right. So authorization is giving access. Okay. I'll also use the example of the hotel. Yeah. When you get to a hotel, you want a room. Yeah. You need to authenticate, like give your ID card to prove that you are who you say you are. Yeah. That's authentication. Verify that you're who you say you are with your ID card. Then at the point of them giving you the key to a room, yeah, that's authorization. They're giving you the key, access to the room. So that's authorization. Yeah, so you have the authority to, once you have the key, you have the authorization to get into the room. So let's look at, this is module 2, where we describe identity concepts. Yeah. Here we'll look at describing the concept of identity as a security perimeter, describe identity-related services, authentication and authorization. Authentication, say AUTHN. Yeah, authentication is the process of proving that a person is who they say they are. Authentication grants access. Yeah. Then authorization determines the level of access or the permissions an authenticated person has to your data and resources. Yeah. So authorization, you're giving somebody access, and also the level of access matters. Yeah. You don't want to give everybody, you don't want to make everybody an admin. Yeah. To be able to create, update, and delete. Yeah. You don't want that. So the level of access matters, the permissions you give your users, yeah, to the data or resources. Okay, authentication is the process of proving that you're who you say you are. When someone purchases an item with a credit card, yeah, like you use your ID card, you could use your ID card to prove that you're who you say you are. Yeah, that's an example of authentication. Yeah, when you want to access a computer or device, you'll encounter a similar type of authentication. They will even, like, when you want to access, or even an application, it would tell you to authenticate. Yeah, your Microsoft, like when you want to access, yes, some applications, it will ask for authentication. You'll need to verify that you're who you say you are. It will send you a code. It will send you a code to your phone, and with that, you could verify that you are who you say you are. Yeah, it may be asked to enter a username and a password, which is the first verification. Then, when he asks for another, the code, that's a multi-factor MFA. Yeah, that's a two-step verification. Mm-hmm. So when combined with a password, which only that user should know, yeah, your password, it allows access to your systems. So the username and password together are the form of authentication. Yeah. And with authorization, yeah, once you authenticate a user, you will need to decide where they can go and what they are allowed to see and touch. Yeah, you give them the permissions, the access, yeah, the level of access. And this is the process. This process is called authorization. Suppose you want to spend the night in a hotel, like the example I gave you. Yeah, the first thing, the reception authenticates you. Then once you get your key, you're authorized to go to your room with the key. Yeah. So here you have an identity which can be used to authenticate and authorize someone or something may be associated with user, application, device. Yeah. And the four pillars of an identity infrastructure, you have the administration, authentication, we've seen that, authorization, yeah, we've seen that, and auditing. What do you understand by administration? Can somebody tell me what is administration? These are the four pillars of an identity infrastructure. Can somebody explain administration to us? Hello? Are we still there? Administration. What do you understand by administration? The word administration, what do you understand? Hello, are we still here?
Yes, we
go
are.
on. Okay, go on, tell us.
Management.
Yeah. Management, administration. Yeah. What else? Anybody else? And what is auditing? And somebody tell us. Like she said, management, administration, the word is, these words, they have been like you could use your, they are English words. So just use just what you know about administration. Yeah. Like she just said, management. Yeah. So administration is about the creation and management of identities for users. Yeah. You're creating and managing identities for users, devices, and services. So as an administrator, you manage how and under what circumstances the characteristics of identities can be changed. I did mention that as an admin, you can create, you can update, and you can delete. Yeah? So an admin has an overall privilege. And we've gone through authentication. Yeah. Authentication pillar tells the story of how much assurance for a particular identity is enough. In other words, how much does an IT system need to know about an identity to have a sufficient proof that they are who they say they are. Once you come across authentication, it's you verifying that you are who you say you are. It involves the act of challenging a party for legitimate credentials. You'll be given, you'll be asked for your credentials, other IDs to prove that you're who you say you are. Yeah. And then authorization. Authorization pillar is about processing the incoming identity data to determine the level of access an authenticated person or service has. So one needs to be authenticated first, then you can authorize the person as within the application of service that he wants to access. Yeah, the level of access person has is authorization. Then auditing is another pillar. It's about tracking who does what, when, where, and how. Yeah, you have auditors auditing an account. Auditing includes having in-depth reporting, alerts, and governance of identities. Yeah, so auditing, that's auditing. We have 10 minutes to go. So I'd like to stop here, and if you have any questions, yeah.
Thank you so much,
Okay.
Madam Franca, for your time.
Thank you. You're welcome.
Thank you everyone for joining us today. Madam Franca has been able to share with us what the cloud computing services models, which are IaaS, PaaS, and SaaS. She also made mention about the CIA triad. She goes further by explaining concept of zero trust methodology, as well as data encryption, hatching, governance, risk, and compliance, among others. Thank you once again for your time, ma'am. Really appreciate you. Is there anyone on this call that have any question so that she will be able to address the question? Thank you. You can just unmute your mic and ask. Thank you once again. Okay, Mr. Shitu, you can go ahead to unmute your mic to ask your question.
You're well done. I've put the question on the chat and it has not been answered. Can you hear me?
Yes,
Hello?
Mr. Shitu, we can hear
Loud
you.
and clear.
I
Yeah,
have
we
the
can hear
question on
you.
the chat already. It's about the hashing. She made mention that we can use hashing to get passwords, like when we have different type of passwords on our applications, then I asked the question that how can we practically use this? I think that's the question I put on the chat today. Thank you.
All right, thank you once again, Mr. Shitu. Madam Franca?
Okay, yeah, I'm here. Okay, I just saw the question, yeah.
All right, thank
He
you.
wants to practicalize hashing. Yeah. Okay, what I'll do is like I don't have the practical. I'm not ready for the practicals today. I didn't come prepared actually for this. It's a makeshift class. Yeah, but I'm going to, your question will be answered in the next class.